Hello and welcome back. So today I'm gonna do something different for this time. I've been getting a lot of requests to know how to do PCB design. So I'm going to explain PCB design using EAGLE CAD software. Now EAGLE is the most PCB software used by hobbyists nowadays, basically because it's free and it's supported by the industry. It has a wide catalog of libraries created by hobbyists and famous components manufacturers. Mainly two libraries we would care about are the libraries created by SparkFun and Adafruit, because they contain mostly any components that a hobbyist would like to use. Uh, Now, disclaimer, there's a lot of tutorials on how to use EAGLE CAD, so don't consider this as the best tutorial, but it should answer some questions, hopefully, for the people who have them. Now, first of all, so go to EAGLE CAD software USA. By the way, any link or web page I will open, I will link it down in the description box below. Now, you can download EAGLE either for Windows, Linux, Mac. I've already went ahead and downloaded EAGLE on my Windows 8. Now, the installation file is here. Obviously, I did not install it yet. Why? Because I enjoy to paint myself instead of doing everything beforehand and moving away all the bugs that might happen during the explanation or this tutorial. I would like to face those bugs and try to work them out. Hopefully they work out and I don't have to edit this video. If you find some sudden shifts in the video or time shifts, know that something wrong happened and I had to fix it. Anyway, so right click here and run as administrator. And waiting. Yes. Set up and it's installing, obviously, so just give that a bit of time. Now, for the people who are using EAGLE for the first time, give it a chance. It might be hard in the beginning, but once you get used to it, it will be easy enough for you. So, next, yes, yes, next, and installing. It shouldn't take about, the setup file is like 44 megs. It's not gonna take a lot of your hard drive, and it's a very very light software. So if you have not a very strong PC or laptop, you don't have to worry about that. So yeah. Okay, since we are using it as the free version, so we will run as freeware. Next, finish, and wait for it to launch. Waiting. Okay, is it planning to launch today or not? Looks like not. Okay, I'll go launch it myself. Okay, EAGLE, here it is. Okay, it would like to create a direct in my document, so yes. Okay, so this is the standard layout of EAGLE when you start with it. So go to projects, open it up, and then go to EAGLE folder, right click on it, and then select new project. I will call this project example. Oh, great, mistype already. Example. It's in front of me also. Okay, so right click on example and new schematic. So understand, In Eagle you have to draw the schematic for the circuit you want, and then you can create a PCB. Some other softwares like one I used before called PCB Wizard, you don't have to draw the schematic, you can just lay out the PCB components and that's it. But this one requires you to lay the schematic and then create the PCB. You still can do the PCB without the schematic, but believe me, if you don't put the schematic, it's a pain to connect in the software. So, and it's considered better practice if you have the schematic in the beginning. So start with the schematic first. Now, since we have already installed Eagle and it's running right now, Eagle has certain type of libraries inside it, which is standard libraries coming from manufacturers and whatnot. But I'm assuming most of you are using components from SparkFun or Adafruit or from any hobbyist equipment supplier. So you would need the libraries for certain components that might not be available already with Eagle. So if I go to my web browser here, so I have two libraries I want to download. One is the SparkFun Eagle library and the Adafruit library, which the links will be linked down below in the description box. So I go ahead and download them. So download as zip files. I prefer to save it in a directory, it's much easier. So desktop, Eagle, save it. Same thing goes for Adafruit. Save link as and save. Once he's finished saving, go to the Eagle folder and you have these two compressed files. So extract here, and for Adafruit also extract here. Now double click, you have the library file, so I'm just gonna copy the library file to the C directory of Eagle. So go to C, program files, and then look for Eagle. So Eagle, and then LBR is libraries, of course. So these are the libraries that are already inside. Some are from supplies you might know, like Altera for FPGAs, and 7.4 is the logic ICs. Okay, so just double click here again, go to Adafruit, copy the library of Adafruit here. Of course, Windows doesn't like you going inside the C file, but tell them continue anyway. Yes, please. Thank you. Again, same thing for SparkFun. SparkFun is a little bit full, but no problem. So take all this. I think that's all the libraries. Yeah, LilyPad, but I don't use LilyPad, but okay. Again, he is not happy. Continue. Yes. Thank you. Okay. Now these libraries have been copied into Eagle's library directory. Now Eagle will not straight away use them, so you have to tell him to use these libraries. So go to libraries and then tell him use. And when you come here, just press Ctrl A, select everything, and then say open. Eagle might not respond for you for a while because he's opening all those huge libraries. Is he ready? Yeah. Okay. Give it time. Okay, so this is all the components inside Eagle. Okay, so what circuit am I planning to build here? My circuit that I'm planning to build is going to be what they say full option, which means it will contain mostly everything you might want to know. It will contain ICs, it will contain electronic components, it will contain motors, it will contain diodes, contain resistors, LEDs, headers, mostly anything you want to use. Disclaimer for anybody who's watching this video, all the components that I'm going to use are going to be through-hole components, not SMD. Okay, so don't complain or say we are still in the Stone Age. In the end, when you are prototyping on a breadboard, you are not going to use SMD. You are going to use through-hole components. Unless they made a breadboard for SMD components and I don't know about, then connect me if I'm wrong. Anyway, moving on. So let's say we have a Raspberry Pi, some of the, what you say, hobbyist favorite playing toy right now, and we wanted to control two motors, make them rotate to the right or left. So when you say motor direction control, that means H-bridge. Mostly the H-bridge that people use for this are two types, either LN298 or LN293. LN298 for this purpose is overkill because that one is like 2 ampere drive current. LN293 is more than enough. I think it's 0.5 ampere per channel, so it should be enough to drive any motor. Small motors, small DC toy motors, not big buffy TC motors. Okay, so to start off, we want LN298, so 293. So let's try typing its name in the search. When you go to the search, make sure you remove the SMD icon because you don't want the search to give you back anything that contains the word that contains SMD components. So in the search box, write L293. A bust, nothing, didn't hit anything. So okay, so the actual search term that you have to use to find the H-bridge is just the actual name of the H-bridge. Sorry, but you know, for Eagle, the search what you say engine inside it's not a genius. It depends on the manufacturer what actual attributes or captions he left for the component, so it will pop up in the search. For this one, just write L293D, and here it is. Okay, take it and place it on your desktop, and then left click to place, and then right click to rotate if you want to rotate it. Sorry, orientation, and just press the escape key to go back to the add window. So after I've added the H-bridge, I would need to add, what do I need? So I need diodes. So let's say I want, which diode? Let's try 1N4001. Nope. Was it 2N? No. Okay, just diode. And yeah, 1N4004. It's the cousin or uncle of 1N4001 or 4002. It's a general purpose diode and it can handle any reverse current. Not any reverse current, but at least high amounts. So I'm going to have two motors, so I will need 8 diodes. So this is one, left click to place, left click to place, left click to place. So 1, 2, 3, 4, 5, 6, 7, 8. This is going to be a bad tutorial. Okay, so escape. After that, after diodes, what do I want? Yeah, let's bring out a capacitor. So capacitor. Well, I have a lot of libraries for capacitors. I prefer to go with this one, which is RSL CEU. So let's see which form factor I like. This is too small, beef it up a little bit. I think this is good enough. So add this one here and this one here. What else? Escape. Ground maybe. Yeah, I need a ground. So GND. Any ground you can use. So this one's ground. Exit. What else? yeah, since this is going to be connected to a Raspberry Pi, I need to connect the Raspberry Pi to the PCB, so I need the header for the Raspberry Pi. So the Raspberry Pi is GPIO pins is like what was it, 26? 1 second. Raspberry Pi pin out. And so waiting for image to load. Yep, 26. Okay, so get a header of 26. Go back to Eagle, write the search header. Okay. Nope, 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 nope. This is single in line. I don't want single in line. I want double in line. Okay. Nope, 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 nope. Going up, going up, going up, going up, going up one more time. Here it is, 26. Okay, 26. Done. Okay. So I've added this header for the Raspberry Pi, but keep in mind one thing. If you look closely here, this is the schematic view and this is the actual PCB view. Keep in mind where is the pin located. So pin number 1 is on the right when you put it on the PCB, which is not matching the schematic. So if you make a connection, you might get it wrong. So the better way of connecting is to make pin 1 on the right so you don't make a mistake. So close this down. Now I want to rotate this one. I've already placed it, so I cannot rotate it. Of course, in Eagle, if you press the mouse button on any equipment, it will not listen to you. You have to go to the toolbar and select what operation you want to do. For this one, I, for example, want to rotate it. So I go to rotate and then go to the center of my schematic. Where is the plus sign? Here. And then just press on it. It will rotate. Yeah. So this is the orientation I want. Okay, so let's lay out everything nicely. Select the move icon, move the edge bridge here, zoom out a little bit with the scroll button, put the header here. Now, of course, I'm not gonna move each diode one by one, so I'll do the following. I will select group and then highlight them all, then go to move, left click on it, and then go back to them and right click on one of them and then select not move, move group. So move the group. Now you can move them all together. So I will place this one here, this one here. I will place it, yeah, good enough. And this one I'll move it here. Yeah, and this one, this is the ground, so move the ground wherever you want. I'm going to move it, yeah, why not? I'll put it here. By the way, while you are moving it, if you press the right click, it will rotate also. So I'll place one ground here and I will copy another one to the other side. So I just go to the copy sign, select an object that I want to copy, press on it. Now you have a copy. Rotate it and place it. Maybe you need to edge this a little bit. Now, to connect objects together, it's pretty simple and straightforward. You don't use these. Don't use wire. Don't ever use the wire. Use net. Okay, so press on net and then go to the tip of where you want to connect. Press left click, then you get a wire. So just move the wire down and then terminate it at the ground. So each move of the mouse the wire increases, and when you press the left click at a location it will fix itself at that point, and then place it here. This dot means that these 2 points are connected. Okay, if you've used the wire, that dot would have never appeared. Okay, I'll show it to you. Here's the wire, connecting, connecting, connecting. Of course, escape to stop the wiring, and then again wire. See, the wire did not create the dot. Okay, so don't ever use wire for connections, use net. So Control Z, remove all this, go back to net and connect the grounds together. Okay, done. Now, since this is L923, I don't quite remember the pinout for this one, so give me a second. L293D. I don't want a hobbyist view, I want a professional view. Not information. Ah, yeah. So VCC1 is logic voltage, and VCC2 is motor voltage. Okay. So why are there two VCCs? Simple. Inside you have two circuits. You have the logic circuit and you have the motor drive circuit. Now to drive the motors, obviously you need a separate supply for them. Maybe your chip is going, your microcontroller or Raspberry Pi, for example, only use 3.3 volt logic. So it's impossible you're going to drive the motors with 3.3. So a separate VCC is made for them, so you can drive them at whatever volt you want and control them with a weak input voltage. So this one is going to be 3.3. So I'll connect the wire from here, 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 and then stop this wire. Now in Eagle you can name wires. So right click on the wire, name, and call it 3.3 VCC. Done. Now the wire is named 3.3 VCC, but you want to see actual name appearing. So how you do that? You go here, label, and then select this form of label, and then go to the wire you want to label, and voila, here you go. Left click again, label is placed. So this now has become 3.3 VCC. And for this one, for VCC number 2, we will name it motor VCC. Label it, right click on it, label. This is a shortcut, by the way. So, and here is your label. Now don't go crazy with the labels. Too much labeling, the circuit will be unreadable after that. So okay, now Y's are the output from the H bridge, which will go to your motor. So we'll connect the capacitor to them. Move this to the center and then use the net to connect. So from this point to this point, and from this point to this point. Okay, and then after that, for the second one, just bring it here. Yeah, and just do the same wiring convention. So net to net, and this one to this one. Done. Now, done with that. Okay. Let's name these wires since they are going to motors. So this one's name is going to be, no, start with the one on the left. So this one is M1. This one's name is M2. This one name is TEM3, and this one's name is TEM4. And of course you have to label them to know what they are. So label, 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 label. Okay, so everything is labeled. Now what still I have? Yeah, enable pins. Since enable pins are usually used to do PWM control for the speed of the motor movement. Since I'm not interested in speed control, I'm only interested in the direction control. So I'll just simply connect enable pins to the 3.3 VCC. So how you do that? Very simple. Just take net and connect from this point, from here to here. Yeah, of course I can make it tidy and connect a label and that's it, but you then get lazy and you will never do any wiring by yourself, or it will just be ending up with a mess of labels. So too much labeling is not nice, and too much wiring at the same time is not nice. So try to conserve. There's always a sweet spot between them. Anyhow, so this is done. Okay, so enables are done, grounds are done, outputs are done. Yeah, so inputs to the edge bridge itself. Let's select which pins are we going to use from the Raspberry Pi. So keep in mind, I2C pin, SPI pins, and UART pins are reserved, hardware reserved, meaning if you try to send values to them, they will not work. They will not respond to you. So the only free pins that you have are GPIO 4, 17, 27, 22, and 23, 24, 18, and 25. Okay. So for this example, I will use 4, 17, 27, and 22. Okay, so let's label some things here. So this point is going to be 3.3. So name it as 3.3 VCC and label. Labeling is important. If you don't do it, you'll lose track. Again, so GPI4 is down by 2 wires. So go again here. And I will name this as GPIO04. Done. Okay, and then next one is after this where the other one is ground, and then 17. By the way, the ground should be connected also, but let me finish these first. So one here, and then one here, and then one here, I think. Yeah, 17, 27, 22. Name GPIO 17. Name GPIO 27. And name GPIO 22. Label them. Labeling in progress. And yeah, as I said before, connect to the ground, because then you will come and say, why isn't it responding to the outputs that are coming from my Raspberry Pi? Well, genius, you did not connect the ground, so an open circuit, so current doesn't flow in an open circuit. So name this one as GND. Yeah, by the way, just for your information, anything you connect to the ground terminal, the wire itself will be named GND. So basically this point is shorting to the ground there. internal. You don't see it, but Eagle understands. Oh, this one goes there. That's it. End of story. So, oh yeah. So let's name them over there also. So I'm not gonna wire one wire from here to there. That's a mess. So make it nice and tidy. Okay. Okay, so this one I will use for it GPIO 04, and this one is going to be GPIO 17, and this one is going to be GPIO 27, and this one is GPIO 22. Label them. Okay. Actually very nice, but I'll move this one from there. So group, and then select all of them, and then select move, and then right click, move group, move them over here. Okay, so done with that part. Now to connect diodes to the output. Now of course these, you're going to connect motors. I'm supposing that the motors you have soldered two wires to the motors and you want to connect them to the PCB. So basically you would use something like this if it's available on the search. Screw terminal. Yeah, like these. So go to Eagle, and in the search for components, write screw, and here you go. Two terminals. So add one here and another one. Yeah, good enough. And then rename them. So this is, name it, what is the name? Yeah, motor 1. And this one's name is going to be motor 2. Done. What else? Yeah, connecting the diodes together with the outputs. Okay, the nice thing about this is that it comes as two separate parts, so I can actually move them apart, which will really help with the connection. I am not going to do a lot of labeling this time because diode connections, you really have to see them, so for you to understand. So I'll take this wire till here probably, and then this wire from till here, and then another wire here, no wire here. So these are supposed to connect to the output from the H-bridge. So name, this is M1, this one's name is M2, and this one's name is M3, and this one's name is M4. Now let's connect the diodes to them. So how you do that? Take one diode, connect them back-to-back connections. Okay. Okay, so this one's placed. Yeah, should label also, not to forget. And just connect the dots as they go. So this point with this point and this point with that point. Okay, and then this one would be connected to VCC motor, and this one would be connected to ground. So name the wire G and D, and name this one motor VCC dash. Yes, I'm sure. Label and label. So if you understand your basic electronics, this is wrong. Great. Wrong connection. Whoops. Yeah, I understand my basic electronics. That's why I saw the mistake directly. How could you put VCC at the anode? Of course it won't work. Genius. GND. This is supposed to be the ground. What the labels, dude? Come on. And here. Yeah. So I was saying before, the huge humiliation I had is that if you understand the basic electronics, so these diodes will never conduct because the anode is connected to ground and the cathode is connected to VCC. There is no possibility of them conducting. When will they conduct? When the coils inside the motor wanted to charge the current inside them, they will conduct either into ground or VCC, but they will not conduct back inside the H bridge, which basically would burn the H bridge. And yeah, the H bridge usually works with you guys during the testing part. Everything is nice, and then you even go to the PCB and it works nicely, and then you come to the presentation day and poof, it doesn't work. Why? Because the motor just gave it a little more spike than usual and burned it. Just your luck. Anyway, so yeah, duplicate this process for the 3 wires. So quickly, let's do this. Sorry, bear with me. I know it's an annoying process, but it's for your own good. Okay, so this one's here, and finally it's ending. Last 2 diodes, so this one here, and this one here. Okay. Seems everything is okay. But what is missing still? Yeah, a source for VCC input to the H bridge to power the motors. That's a simple thing. Just get another screw terminal and that's it, and input your power to it, VCC and ground, and that's it. So I'll go again to place component, take a screw terminal, put it here, exit. I'll rename it as name power, and then label it. So this one I'll take a ground, so ground from here. Come on, give me a ground. I don't want a wire. I want a ground. Okay, so ground here, connect power, and for here, this one, drag a long wire here and call it name motor VCC. Yeah, label and done. Okay, just for the sake of people who love seeing LEDs, I will add one LED for you. That indicates that there is power going into your circuits. Actually, okay. Extra advice for you people, whether you like it or not, you're gonna take it. So generally you will not have this problem with the Raspberry Pi, but this is an extra advice for people who are using microcontrollers like Arduino or PIC or AVR or STM. They connect everything and it does not work for a simple reason, my friend. These motors are still spiking your VCC and ground. So that nice spike goes into your microcontroller and restarts it, or in other cases it kills it. Now the nice thing about Raspberry Pi, that it already has all the filter caps it needs to remove all those spikes. So all you have to do is just add some filter caps and that will remove the spikes. So I will copy one capacitor, add it here, and add another capacitor here. So I'll connect them in parallel with the input voltage. So the only job for these capacitors is to remove the spikes that would arise from the motors on your VCC. Now generally you place one of them in the nanofarad range and the other one is in the microfarad range. So let's say 100 nanofarad and the other one 100 microfarads. Okay, LED. Place components. First resistor before LED. Resistor. Yeah, this looks nice. Okay. And then LED. So that's LED. LED 5mm. You would take it from the Adafruit library. Okay. Adding LED. That's it. Now move this a little bit down. Connect the wires. And with that, your schematic is complete. So you have GPIO pins from your Raspberry Pi controlling the H bridge, which is controlling two motors connected to its output, and the VCC for the H bridge here is coming from an external source. I will consider this as part one of the video. I will continue later on. I was planning to do this all in one go, but it's it's really tiring and it's taking a lot of time to do. So I'll end the video here, and then I will go into the PCB design part. Thank you for watching.